Welcome to today's Explainer. Today, we're going to put on our detective hats and act as investigators uncovering the true building blocks of science and integrity. If you've ever wondered how a simple, everyday idea transforms into a universal rule that literally governs everything around us, well, you are in the perfect place. We're not just going to read off a bunch of textbook definitions today, we're exploring the entire framework of how we actually understand our world. Let's dive in.
Here's our quick agenda for today's Explainer. We'll start with the search for truth, walk step by step through hypotheses, theories, and laws, put them to the test, and finish up with how these concepts actually tie into morality and peace.
All right, Section 1, the search for truth, science and integrity. Let's get right to it.
Now, science is, at its absolute core, a search for truth. And as 2 John 1:2 reminds us, seeking truth is both a scientific endeavor and a deeply moral imperative. It sets our foundation absolutely perfectly. Organizing data accurately is exactly how we honor that truth.
So here's the crucial point. Mastering these scientific words prevents a whole lot of confusion. I mean, you've definitely heard people misuse these terms in daily conversation, right? Or even on the news. By knowing exactly what these words mean, you actively prevent yourself from spreading misinformation. And honestly, speaking with that kind of clarity and precision makes you a highly credible communicator.
Moving right along to Section 2, Hypothesis, the educated guess.
Imagine you're starting a brand new experiment. You don't just throw on some safety goggles and start mixing random neon liquids together hoping for a superpower, right? You begin with a hypothesis. This is your specific, measurable prediction of what's going to happen. It's educated because it's based on things you already know, and it is absolutely vital that it can be put to the test.
Let's look at a real-world example to make this concrete. If we compare blue light versus red light on plants, we get two extremely clear variables we can easily test and measure against each other. Our condition is the color of the light, and our predicted outcome is how tall those plants are going to grow. It's clear, it's direct, and it is totally ready for the lab.
So whether you're testing plant light or, say, how caffeine affects someone's reaction time, your hypothesis literally has to hit 3 marks. You must be able to test it, you've got to specify the details, and you must be able to measure the results. If you just say caffeine makes people better, well, that's way too vague. But predicting a specific decrease in reaction time? Now that is a rock-solid hypothesis.
Okay, Section 3, Theory, the big explanation.
The defining characteristic here is repeated evidence. This is the exact opposite of a random guess. A theory only exists after a hypothesis has been tested relentlessly, over and over again, and the data continually supports it. It graduates into this robust, comprehensive explanation for why something happens in nature.
I mean, think about the sheer scale of these examples. The theory of plate tectonics explains literal earth-shattering events, earthquakes, the formation of giant mountains, volcanic activity all over the globe. And then on the flip side, germ theory explains how microscopic, invisible invaders cause illness. They don't just state that these things happen, they explain exactly how they happen based on mountains of gathered data.
So, is a theory just a guess? I really want you to think about this question for a second, because it's probably one of the most common misconceptions you'll ever hear in the real world. Someone might brush something off and say, well, I don't believe that. It's just a theory.
Absolutely not. No way. By understanding that a theory is actually a well-supported explanation built on hard, repeated evidence, you are already communicating with so much more scientific accuracy than most people. In the scientific community, graduating to the level of a theory is a massive achievement. It requires rigorous, undeniable validation.
All right, Section 4, Law, the consistent rule.
Now here's the key distinction. While a theory explains how or why something happens, a law simply states what consistently happens under certain conditions. It's an undeniable pattern in nature. Often it's something you can express with a neat mathematical equation. It doesn't explain the mechanics behind the curtain, it just tells you exactly what the curtain is going to do every single time.
Take a look at these 2 famous laws that you can observe repeatedly anywhere in the universe without fail. Newton's law of gravity consistently describes how masses attract each other, and the law of conservation of mass tells us that in a chemical reaction, mass is neither created nor destroyed. These are the consistent, totally unbreakable rules of the game.
Moving on to Section 5, Put it to the test. Let's see how this all connects.
This sequence right here answers the age-old question of how a simple idea grows into a grand scientific truth. It's like a giant puzzle. You start small with a testable guess. Then you put in the hard work, conducting experiments and gathering that repeated evidence. Finally, when the evidence is absolutely undeniable, those findings integrate into a larger, well-supported theory.
Okay, take a quick second and think about how you would frame this using our rules. Don't just say, exercise changes your heart rate. Remember, we got to make it testable, specific, and measurable. So maybe something like, if a person does jumping jacks for 2 straight minutes, then their heart rate will increase by at least 20 beats per minute. See? That is a solid scientific starting point.
Finally, Section 6, Education, Morality, and Peace.
Knowing the exact difference between a hypothesis, a theory, and a law isn't just about passing a science test. That actually allows you to uphold the truth and demonstrate real integrity in your everyday life. When you use your understanding of data to speak accurately, you are actively choosing to not spread misinformation. Your scientific accuracy basically becomes a direct reflection of your character.
The Heroes Mart Academy Godly Learner series intertwines biblical morality with education to teach us a really profound lesson. Education without morality will hurt. Think about it. What is the actual point of being super smart, of knowing the strict difference between a theory and a law, if we just use that knowledge to make bad choices that end up hurting ourselves and others? Knowledge absolutely has to be guided by a strong moral compass.
When you align a rigorous scientific education with strong moral integrity, you unlock something incredible. Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. When you align your search for factual truth with a deep commitment to moral truth, the result is profound peace. And honestly, this is a reality experienced by so many who embrace this balanced approach to learning.
So, I'm going to leave you with that final question to ponder. As you step out into the world, now fully equipped with a clear understanding of hypotheses, theories, and laws, how will you use your pursuit of scientific truth to make choices that bring peace? Apply both that sharp scientific mind of yours and your strong moral compass. Thank you so much for joining me on this explainer today. Keep questioning, keep testing, and always keep seeking the truth.